Welcome. Today we're putting on our architect hats to design a digital fortress. Our mission? It's simple. To protect your most valuable asset on Google Cloud Platform, your data. Okay, so let's just dive right into the core of the issue. At the heart of every single modern data strategy, there's this fundamental tension, this balancing act that every organization, big or small, has to master. You see, on one hand, you absolutely need to empower your teams. You want your analysts, your data scientists, to have really broad access to data so they can find those golden insights, drive the business forward, and just move fast. But on the other hand, you have this absolute non-negotiable responsibility to protect sensitive information, especially personally identifiable information, or PII. So that's the real challenge, right? How do you open the doors for innovation without leaving the entire vault unlocked? So our very first layer of defense, it all starts with a simple but really powerful question. Who is even allowed to approach the fortress in the first place? This is all about identity. And this is exactly where identity and access management, you'll hear it called IAM, comes into play. You should think of it as the bouncer, the fundamental gatekeeper for your entire cloud environment. It's not just about letting people in. It's about defining exactly who they are, what they're allowed to do, and which specific resources they can even touch. Now, what's really powerful here is how GCP lets you apply these controls with just incredible precision. As you can see, you can start really broad at the project level, maybe give a whole team view-only access. Then you can get way more granular at the dataset level. And finally, you can drill all the way down to grant access to one single specific table. This hierarchy is absolutely key for fine-tuning your permissions. So here's the bottom line. This layered permission model is your first and, frankly, most important line of defense. It makes sure that only the right people with the right permissions can even get to the front door of your data. Okay, let's move on to our next layer and see how this all builds up. Because even authorized users, people you trust, need boundaries. I mean, having the key to the front gate doesn't mean you should be able to just walk out with the crown jewels, right? All right, now we're going to talk about building the actual fortress walls. And on GCP, we do this with something called VPC Service Controls. It's a really powerful concept for creating a secure digital perimeter around your resources. So VPC Service Controls, we'll call it VPC-SC for short. It basically lets you draw this virtual line around a group of your GCP projects and services. And any data that tries to move outside this line, it just gets blocked. It's specifically designed to prevent data exfiltration, which, is just a fancy way of saying data theft. And here is where you really see its power. Imagine an attacker manages to steal an employee's credentials. They have legitimate access inside your perimeter. But the moment they try to copy your sensitive customer data out to their own server, bam, VPC-SC slams the gate shut. That data simply cannot leave your trusted network. Okay, so now we're inside the walls, and we know who is allowed to be here. Now we have to secure the actual treasure, the data that's sitting in the vault. How do we let people work with it without just exposing everything? This is where we get super granular. With column-level security, you can make entire columns, like a social security number, completely invisible to certain users. I mean, they can query the rest of the table, but for them, that column doesn't even exist. Data masking is a little different. It still shows the column, but it obscures the data, kind of like showing only the last 4 digits of a number. This is incredibly useful for, say, development and testing, where you need realistic-looking data without exposing the real stuff. Okay, let's consider a total worst-case scenario. What happens if an attacker bypasses all of these controls we've set up and somehow manages to physically copy the underlying encrypted data files right out of storage? Is it game over? Nope, not if you're using Customer-Managed Encryption Keys, or CMEK. See, by default, Google manages the encryption keys for your data. But with CMEK, you control the keys. So if an attacker steals that encrypted data file, it's just a useless jumble of bits to them. It's unreadable garbage without your key. You hold the one and only key to that lock. A fortress isn't truly secure without a really good surveillance system, right? You need to know what's happening at all times. And that brings us to our final, and maybe most critical layer of defense, active auditing. Google Cloud's audit logs are basically your eyes and ears. They give you a detailed, unchangeable record of everything that happens in your environment. They track exactly who did what, when they did it, and from where. This is your digital paper trail for every single action. And the reason this matters so much is simple. You can't protect what you can't see.
Auditing gives you that crucial visibility to perform security analyses, to prove compliance to regulators, and, if the worst should happen, to conduct a thorough forensic investigation to figure out exactly what happened. So we've covered the gatekeepers, the walls, the vault, and the surveillance system. Let's put it all together now into a practical blueprint that you can actually go out and use to build your own fortress. Here it is. This is your master checklist for a real defense-in-depth strategy. It all starts with IAM, following that principle of least privilege. Then you build your perimeter with VPC. You have to know what you're protecting, so you classify your data. Then you apply those granular controls like masking. You take control of your encryption with CMEK. And finally, you keep a constant watch with your cloud audit logs. You see, each layer reinforces the others. So we'll end with this final thought. Security is never a one-time setup. It needs constant attention. So you have to ask yourself, is your security an actively defended fortress? Or is it more like a static museum piece, just waiting for someone to find a crack?